See, post-fertilization, its structure and events. First one is development of endosperm. See, when the endosperm forms, before the development of embryo, endosperm starts forming. How the endosperms are formed? First, the primary endosperm cells divides repeatedly and form endosperm tissue which are triploid in nature. These endosperm tissue store food materials, and these stored food materials are utilized by the developing embryo and also at the time of seed germination. I'll repeat again. These stored food materials are used by the developing embryo and also at the time of seed germination. So what is present in the endosperm? Food is present in the endosperm. The endosperm is of three types. We'll see the types of endosperm. First one is nuclear endosperm or free nuclear endosperm. Second one, cellular endosperm. Third one is helobial endosperm. We'll see the first one, nuclear endosperm or free nuclear endosperm. This type of endosperm is found in dicotyledon, that is polypetale. It is also present in capsula. See, these type of endosperm develops by very important free nuclear division in which cells? Primary endosperm cells. See these one. When the male gamete fuses with this polar secondary nucleus, this form primary endosperm cells. These undergoes repeated division and thus a multinucleated endosperm is formed. Later only cytokinesis takes place. Now you can see here these are the endosperm and you can see the developing embryos. So what is endosperm? Endosperm stores the food materials which nourishes the developing embryo and it is also utilized by the seed at the time of germination. And this nuclear endosperm or free nuclear endosperm is common in angiosperm. It is common in angiosperm. Next type is cellular endosperm. In this type of endosperm is found in gamma petale group. So you can see during the development, that is each division of primary endosperm nucleus. See, primary endosperm nucleus divides and then later after the division, cytokinesis is followed. That is cell wall formation occur and you can see each one become a individual cells. And this type is called a cellular endosperm. Then later they develop into what? Endosperm. See the developing embryo, it utilizes this endosperm. Then next one is helobial endosperm. See during this development of this type of endosperm, first division, that is this is the primary endosperm nucleus. It is followed by unequal cytokinesis. It is followed by unequal cytokinesis. So you can see two unequal size of cells are formed. That the cells towards the micropyle is large. Later, free nuclear division takes place in each cell. This cell and also this cell also. Free nuclear division takes place and it becomes what? Multinucleated. Following this, cytokinesis also takes place and then it changes into cellular endosperm. So this helobial endosperm is an intermediate type of endosperm and this type of endosperm is found in order helobials. What is the difference between nuclear endosperm and cellular endosperm? Here the cytokinesis is followed later only, but here when the nucleus divides, along with that cytokinesis also takes place. The next one is, you can see here some special points. Endosperm is absent in Orchidaceae, Podostemataceae and Trapeziae. And usually the endosperm are triploid in nature, but diploid endosperms are found in Enothera. Mosaic endosperms are found in maize and tomato. Then in this type of endosperm, patches, you can see color patches in this. This type of endosperm is called mosaic endosperm and it is found in maize and tomato. Next, ruminate endosperm. This is found in Ericaceae and Anonaceae. That is, the endosperm is having rough surface. It is having what? No? Roughly surfaced. That is called as ruminate endosperm. Roughly surfaced endosperm is called as ruminate endosperm. It is found in Ericaceae and Anonaceae. Then the drinking endosperm, it is found in coconut. The coconut water is the drinking endosperm. It's what type now? Nuclear endosperm. And the edible part of the coconut is what type now? Cellular endosperm. Next, let us see development of embryo in dicot. This development of embryo was discovered by Hanstein in which plant now? Capsella. See, the embryo develops at which end? Micropylar end of the embryo sac. Where the embryo develops? It develops at the micropylar end of the embryo sac where the zygote is situated. See, most of the zygote divides. When the zygote divides, only certain amount of endosperm is formed because endosperm only nourishes the developing embryo. So, after certain amount of endosperm is formed, then only the zygote divides. This adaptation is, why this adaptation they are having? Because then only they can get what? Nutrition to the developing embryo. Okay, the first division of oospore is transverse. You can see here transverse division occur. Two cells are formed. The two cells, the one cell which lies towards the micropyle is called basal cell. The one cell which lies towards the micropyle is called as what cell? Basal cell. The other name for basal cell is suspensor. That is called as what? Suspensor. Then the other cell which lies towards the chalaza is called as apical cell or terminal. Apical or terminal or embryonal, or otherwise called as what? Embryonal. So two types of cells are formed. The one which is formed in micropylar end is called as what? That is basal cell or suspensor cell. The other which is towards the chalazal is called as apical cell or terminal cell or embryonal cell. See, this basal cell, otherwise called as what cell? Suspensor cell, and also the embryonal cell divide simultaneously. அதாவது இது divide ஆகும்போது இதுவும் divide ஆகி போயிட்டே இருக்கும். The embryonal cell undergoes mitotic division and gives rise to proembryo. See, this is the proembryo. What is the shape of it? Globular. And what shaped? Later it become what? Heart shaped and then become mature embryo. Okay, so the embryonal cells only divide what division? Mitotic division, and gives rise to the proembryo, and subsequently it forms what shape? Globular embryo, and then heart shaped embryo, and then mature embryo. Then what happened to this basal cell or suspensor cell? The suspensor cell also undergoes what division? Transverse division. You can see here, forming how many cells? No, 6 to 10 celled. 6 to 10 cell and form long filament-like structure, and this is known as what? Suspensor. Then what is the function of this suspensor? This suspensor push the developing embryo into food laden endosperm. அப்படியே endosperm நோக்கி இந்த எம்பிரியோவை புஷ் பண்ணுங்க. ஏன்னா அப்பதான் endospermலேருந்து இந்த developing embryoக்கு என்ன கிடைக்கும்? நியூட்ரிஷன் கிடைக்கும். Okay. Then the micropylar cell or the suspensor cell swells up, and the cell of suspensor is also known as haustorial cell. It is also known as what cell? Haustorial cell. See, in capsula, what is the position of the ovule? No? It is curved. So the embryo also becomes what? Curved. This curved position is called as torpedo. This curved position is also called as what? Torpedo. That is mature embryo. And there is an axis present between the plumule and radicle. There is an axis. See, there is an axis present between the plumule and the radicle. That axis is called as what? No, embryonal axis. That axis is called as what? Embryonal axis. It is also called as tigellum. It is also called as what? Tigellum. Okay. Then the both cotyledons are, you can see here, both the cotyledons are present in which position? No? Lateral position of the embryonal axis, and you can see plumule is found in the terminal position of which embryo? Dicotyledon embryo. So these type of development of embryo is known as what type? No? Crucifer type. This is known as what type? Crucifer type, or otherwise called as onagra type. This is type of development is called as what? Crucifer or onagra type. This is the most common type of embryo development in dicot, that is crucifer or onagrode. This type of development is most common in which one? That is dicots. Then crucifer type of embryo development is found in capsella. Okay, next we will see development of embryo in monocot. Sorry, this one, development of embryo in monocot. See, the early stage of embryo development in monocot as well as dicot is similar up to which stage? You know, globular stage. Okay, now we see the development in the monocot. Example, grasses. See, in grass family, you can see the cotyledon. The cotyledon is called as scutellum. What is the cotyledon called as? Scutellum. It is what shaped? No, shield shaped. What is it? Shield shaped. That is situated towards the lateral side of embryonal axis. That is situated towards the lateral side of what? Embryonal axis. At its lower end, the embryonal axis has a, you can see here, what is this? Radicle. What is this? Radicle, and the root cap also you can see. And this radicle and root cap are enclosed in enclosed by coleorhiza. What is this coleorhiza? Undifferentiated sheath. What is this coleorhiza? It is an undifferentiated sheath. And the portion above the embryonal axis, the level of attachment of scutellum is called as epicotyle. See, that is called as what? Epicotyle. Epicotyle. This epicotyle has is having what apex? No, shoot apex, and a few leaf primordia enclosed in a hollow foliar structure called coleoptile. So, in coleorhiza, radicle and root cap. In coleoptile, what is found? Shoot apex, as a few leaf primordia and foliar structure are found in where? Coleoptile.